Hi everybody and welcome to 3.1 approximating areas under the curve. If I want the derivative, I'm going to go this way. You can see this is the derivative and what we get is the slope of the tangent line. If we go this way, this is integration. We would get the integral. And that's a symbol for the integral. We'll go over all that, of course. And we don't know what we're going to get from that, but we do get something. This is what we're going to try to answer today. What are we getting and how do we get it? Let's start with this example. Suppose a car travels on a straight road at a constant speed of 40 miles per hour for 2 hours. Y is in miles per hour and X is time in hours. And if I went for 2 hours, I'd be going 40 miles per hour times 2 hours. This would cancel and I'll get 80 miles. We know that distance equals rate times time. Rate would be the velocity, time is our hours. Now, what does that mean on this graph? Notice this is 40 miles per hour high, and this is in time 2 hours. To find the distance on this graph, I need the area, this area. This area would be width times height, and our width is 2 and our height is 40, which gives me 80 miles. Either way, we get the same thing. And important to notice that what we're finding here is the area. Now, suppose a car travels so that its speed increases steadily from 0 to 40 miles per hour for 2 hours. It's increasing here until it gets to 40 miles an hour at 2 hours. How far has this car gone? We don't have a constant velocity, but it's really the same. If I want to know how far this car has gone, I want to find the area between the graph and the x-axis. And if I want to find that area, it would be area equals 1/2 base times height, which is equal to 1/2. My base is 2. My height is 40. This is 40 miles because the area from the curve to the x-axis will give me my distance. The definite integral and the signed areas, and signed we mean positive and negative. So if the function is positive, the signed area is positive. If the function goes below the x-axis, if the function dips below the x-axis, the area of the regions below the x-axis are negative. In this case, basically when it's negative, we cannot call it simply area. Negative areas subtract from the definite integral. So if we have a definite integral, it would look like this. It's definite because we have a start point and we have an end point. An indefinite integral, we would just have the function, we wouldn't have the beginning or end. What that means is we want to take the area above the x-axis and subtract the area below the x-axis. For example, if I had a curve that looked like this, whatever this area is would be positive, and whatever this area is would be a negative value. If this was positive and this is negative, then we would subtract the blue from the yellow. As an example, if the function changes signs, then we should subtract the total area below the axis from the area above the x-axis. If we want to know what this area is, which is the net area, if I were to add all those together, I would get my total area. But my net area is from 0 to 3 of the function f of x dx plus from 3 to 5 of f of x dx plus the integral from 5 to 7 of f of x dx. And I'm writing f of x dx because I don't know what the function is. But they're telling me that the area from 0 to 3 is equal to 5. The area from 3 to 4 is equal to 3. And the area from 5 to 7 is equal to 2. 5 is positive, 3 is negative, 2 is positive. We get the net area. Now, what if we have something like this? We want to find the integral from 1 to 3 of this function x plus 1. We don't know how to integrate yet. We just really want to find the area under the curve. I can put a line there, and I know now I have a rectangle and a triangle. And the area of this rectangle is going to be base times height, which is equal to 2 times 2, which equals 4. Now I have my triangle. The area of a triangle is 1/2 base, which is 2, from 1 to 3, and the height is from 2 to 4. Again, it's times 2, but it's half of that. So it would be 4 divided by 2, which is 2, which means that the area of this graph is equal to 6.